Hello, girls and boys. It is Mr. McAndrew, the math coach. As always, very excited to be with you. You have been doing multiplication and division for a little while now. You've been doing some word problems, right, to figure it out. Here, let me move myself up right now. You've been writing equations like 6 times 3 equals 18. And you've been doing a lot of what we call visual models that are drawings, number lines, arrays, equal groups, sets of equal groups, did I say area model, to visualize what it looks like and to help you understand it. So what we're going to be doing this week is looking at those 3 parts of multiplication and division and how they connect. So, for example, we have word problems, right? And we have visual models, okay? And then we also have equations. Like I said, 6 times 3 equals 18. Or sometimes we just have an expression, which is just 6 times 3 without the equal sign, okay? So we have 3 things, right? And to be really good at this, what you want to be able to do is, if you're given a word problem, is to be able to model it and come up with an equation to solve it, okay? Or if you're given a model, can you come up with an equation or expression that represents the model? Okay, or if you're given an equation or an expression, can you then make up a model that matches it or a word problem? Okay, so these all need to be able to connect. All right, so that's what we're going to be working on this week. Today, we're going to work on word problems. Okay, I'm going to give you some word problems, and we're going to work on modeling it. So, for example, right, if I have this word problem, which says there are 5 swings at the park. On each swing, there are 2 children. How many children are there at the park? Okay, so let's model it. I'm going to model it 2 different ways. Model 1 and model 2. So one way I could do it is equal sets of equal groups. So there's 5 swings. So let's say there are 5. I don't want to actually draw the whole, swing set. There's 5 swings, and on each swing there are 2 children. Okay. So put 2, 2, 2, 2, and 2. All right, so I can see that's a model that represents that. Okay, another way I could do it is number line, right? So there's 5 swings at the park. Each swing there's 2 children. Okay, so there's 2 children on one. There's 2 more on another. There's 2 more on another. There's 2 more on another. And there's 2 more on another. So that's 1, 2, 3, 4, 5. So each jump represents a swing. And since there's 2 students on each swing, 2 children, we have 10 children. So 2, 4, 6, 8, 10. We get 10 here. 5 groups of 2 equals 10. So there's my equation, right? And over here I have the same thing. 5 groups of 2 gives me the answer. Okay. So there's lots of ways that we could model this. All right, I could even do an array, right? I could do, there's 5 swings, so maybe each row represents a swing. So that's one swing with 2 students, 2 swings, 3 swings, 4 swings, 5 swings with 2 students. So I can see I have, right, it's 1, 2, 3, 4, 5. I have 2, 4, 6, 8, 10 students on the swing. So that would be more like an array. Okay, so let's come to your math packet. So please take out your math packet. All right, boys and girls, so your math packet looks like this, grade 3, November 2nd to 13th, okay? And turn to the first page where it says Monday word problem practice number 1. All right, so let's take a look. So today's focus, remember, is I give you a word problem. I want you to come up with 2 different models that can represent that word problem. And then we'll solve it. Okay, here we go. So it says Dan needed a really long rope. It doesn't say why, but he does. Maybe for his boat, I don't know. So he tied together 3 ropes that were each about 7 feet long. Okay, so we want to get a visualization. You want to picture what's happening here, okay? 3 ropes, they're each about 7 feet long. That's about taller than me. How long was the new rope? Okay, so it's about 7 feet, so we're going to get an approximate answer here. So one way to do it is the number line, and another way to try it is a set model. So what I want you to try right now is pause the video, okay, and I want you to try doing it with the number line. When you've tried the number line, then come back and we'll go over it together. Okay, so pause the video and I'll see you in a few minutes. All right, so welcome back, boys and girls. So if we have a number line, we can just draw an open number line, which means there's no numbers. We just make them ourselves. We always start at 0, right? There's always a 0 here. And he says there's 3 ropes that were about 7 feet long. So let's pretend that from here to here is 7 feet. Okay, so that's 1 rope right here. And then there's another one of 7 feet. So that's going to get us to what? 7 and 7 more gives us 14. And if we have another one of 7 feet, that's going to get us to 21 feet. 21 feet. So it says, how long was the new rope? So we could answer that by saying 21 feet. Okay, and here's our visual model of what that could look like. There's 1 rope here, there's another one here, and there's another one here. 7 plus 7 plus 7 gives us 21. So we just did 3 ropes of 7 feet equals 21. Okay? Now over here, I want you to try drawing it a different way. Can you represent this word problem using a set model, which means equal groups like I was doing just before with the kids at the park on the swing? All right, try that, and then when you've tried it, come back and we'll go over it. Okay, so pause the video, and I'll see you in a minute. All right, boys and girls, how does that go? I think the number line model is the best model for this word problem, don't you think? But you could do it with a set model, right? You could say, well, I've got 3 ropes, so I could say, like, maybe there's a rope, and there's a rope, and there's a rope, and each rope is 7 feet, right? So that's 7 feet from here to here. So if I were to put all those together, I would have 7 plus 7 plus 7 would give me 7, 14, 21 feet, right? Or 3 sets of 7 equals 21. So something like that would work, okay? So what is the expression used to solve this? Now the expression does not include an equal sign. It's just 2 numbers either multiplied or divided together. Okay, so expression used to solve would be, in both cases, 3 groups of 7. 3 ropes, right? 3 ropes of 7 feet. In our equation, that's when you actually solve it. 3 times 7 equals 21. Okay, so we've answered the question. We were given a word problem. We were able to model it in 2 different ways and show both the expression and the equation that represent the problem. When you take your assessment on this, there'll be questions that use the words expression and equation. So I want to make sure you understand what those mean. All right, let's go on to the next problem. Here is another problem. Okay, it's a little bit different. It is a rope, okay, but it's different. I'll give you a hint. It might be division, okay? I want you to try doing this with the number line and the array. All right, and then I'll come back and work with you a little bit on that as well. All right, so pause the video and I'll see you in a few minutes. All right, so boys and girls, this one's a little bit more challenging than the last one. She does have 20 feet of rope. I think a number line is our best model in this case. So I'm going to use the number line right now. I'm going to draw it. And I know that this is 0 and this is 20. So one way we could do it is we know that each piece of rope has to be 4 feet, right? So we can go 4, 8, 12, like that. We could also go backwards. So we could say, well, we've got 20 feet. If we cut off 4 feet, right? If we go back and cut off 4 feet, now we've only got 16 feet left. But we've got one rope right here, okay? One rope right there. We call this strategy repeated subtraction. Instead of adding up, we're going to subtract backwards. So that's one rope. We can make another rope with 4 feet. And that would get us to, so if we cut off 4 more feet, we now only have 12 feet left, right? Because 16 minus 4, right? We took away 4, we took away 4, now we have 12 feet. We still have more rope left. We still have 12 feet. All right, so let's take away 4 more feet. So if I cut off 4 feet from 12 feet, how many feet of rope do I have left? So 12 minus 4 is 11, 10, 9, 8. All right, so we still have 8 feet left, and we have 3 ropes. We have, let me change my marker here. We have this rope, 1, 2, 3. We have 3 ropes. All right, we still have 8 feet. How many more ropes can we make with 8 feet? We can figure that out, right? Let's do this and then this. So we took away 4 feet, and that left us with 4 feet left, so that's another 4 feet. If we take 4 feet away from 4 feet, we're left with no more rope. So the question is, how many ropes could we make from 20 feet of rope if each rope was 4 feet? Well, let's count. We made 1, 2, 3, 4, 5 ropes. So 5 ropes. I'm going to write that here. 5 ropes. Okay? All right. What's the expression used to solve it? So remember, expression does not include the equal sign. So we had 20, right? We divided it into ropes that were 4 feet long. And that gave us 5 ropes. Okay, so our expression would be 20 divided by 4. Okay? All right. And our equation would be 20 divided by 4 equals 5. All right, now you'll notice over here, I've left another couple lines that we can write. So there must be another way to do this. So let's think about this. Could we write a multiplication expression or equation that would have helped us solve this? Multiplication. So one way to think about this is like this. We knew that each rope was going to be 4 feet long. Okay? So actually, I'm not going to do the expression. I'm going to do the equation. It makes more sense to do the equation. So we knew it was going to be 4 feet long. If we multiply 4 times something, we don't know what, it's going to give us 20. So 4 feet, right? 4 feet times how many ropes is going to give us 20? We figured out it was 5, right? So 4 times something, we're going to say is 5, equals 20. We'll talk more about this in the next video. So there's one more video to finish up for today, and so I'll see you over there in just a minute.